Hi everybody. This video is about converting a quadratic function from standard form to vertex form. So the quadratic function that you see here, y equals x squared plus 6x plus 10, this is called standard form. Vertex form is where we'll be able to graph and see certain features of the parabola without doing much work. So I've listed the procedure for converting to vertex form over here on the right side of the screen. Now be careful, after we get done, it's going to look like this is a two-step process, and it kind of is, but there's a lot to keep track of. So step number 1 says you factor the leading coefficient out of the first two terms. Now that doesn't apply to this first problem because the leading coefficient is 1. We have 1x squared, so there's nothing to factor. However, I do want to keep these little additions in mind. It says leave a blank space and shift the constant to the right. So what that means is, if we had factored out a leading coefficient, we would have used a parenthesis to factor it, and we would have factored it out of the first two terms. Now what we're doing is we're getting ready to complete the square. So just like when solving an equation by completing the square, you leave a blank space. I'm going to close that parenthesis, and I'm just going to shift the constant term, this plus 10, I'm going to shift it to the right. So step number 2 says complete the square. Just as a reminder, this is that half and then square technique that we used when solving equations by completing the square. So we look at the linear term, 6x. Half of 6 is 3. 3 squared is 9. So I'm going to add a plus 9 into this blank space. Now, normally when you're doing equation solving, you would add a 9 on the left-hand side as well. However, for various reasons, we typically don't like to do anything on the left-hand side when we're dealing with functions. So rather than adding a positive 9 on both sides, here you see the addition, it says balance, don't add to both sides. So rather than adding 9 on the left-hand side, I'm going to balance out a plus 9 with a minus 9. So I haven't changed my function. I added a plus 9, I added a minus 9, those things cancel each other out. So I haven't changed my function. The last step says factor, and then you're done. Just like in completing the solving equations by completing the square, this trinomial, x squared plus 6x plus 9, will factor into a perfect square. We have x plus 3 quantity squared. The two numbers that are outside of the parenthesis, you just combine. Plus 10 minus 9 is plus 1. So now the quadratic function is written in vertex form, and we can do whatever we'd like with it. I'll have a follow-up video on graphing in vertex form shortly. So that's the basics. Of course, we skipped over step 1 because there wasn't a leading coefficient. So in the next two examples, we'll see better, more complex examples. I want to leave the right-hand side of the screen there, and here we have another quadratic function. It doesn't matter that we've switched notation. Instead of y equals, we're using f of x equals. We're going to start using this notation more since quadratic functions are quite a bit more interesting than linear functions. So now step 1 applies. It says factor the leading coefficient out of the first two terms. And notice 2 is underlined in red. There's a reason for that. The most common mistake that happens when converting to vertex form is dealing with this leading coefficient. So we have our function f of x equals. The leading coefficient is negative 2. So I factor that out of the first two terms. If you're solving an equation by completing the square, you would divide both sides by negative 2. But remember, we're not doing anything on the left-hand side for various reasons. So I'm just going to factor out the negative 2. And when I say factor, you can basically think divide. Very similar. Negative 16 divided by negative 2 is positive 8. I'm going to leave a blank space, close the parenthesis, and I'm going to shift the negative 31 to the right. A very common mistake is students forget the red underline, and they'll factor the 2 out of this 31, or they'll leave the 31 inside the parenthesis. So try to remember, only factor out of the first two terms. Step 2 says complete the square. The linear term is 8x, half of 8 is 4, and 4 squared is 16. Now, this is not really a 16. I know it looks like a 16. There's a 1, there's a 6. That's a 16, obviously. Not really, though. Remember, you have factored out this -2. This -2 sitting next to the parenthesis means multiplication. If you were to undo this, you would have to use the distributive property. So, this 16 in red is not really a 16. If you multiply -2 times 16, this is really a -32. And we balance out a -32 with a +32. So, next step is to factor. F of x equals -2. This trinomial in parenthesis will factor into a perfect square. X plus 4, quantity squared. And then the two numbers outside, you just combine. -31 plus 32 plus 1. So, the two most common mistakes are, number one, factoring the leading coefficient out of the constant term or leaving the constant term inside the parenthesis. And then the second most common mistake is balancing out this +16 with a -16, which doesn't make sense because, again, this 16 is not really a 16, it's a -32. Okay, let's do one more example, and give me a moment to erase. I want to keep the right-hand side of the screen there. And you can see what students dread, having to deal with fractions. So, step 1, factor the leading coefficient out of the first two terms only. So the leading coefficient is -1/2. And when I say factor, you can think divide. -1/2 divided by -1/2 is +1. That's kind of the whole idea here. Now, 5/2 divided by -1/2 is -5x. If you have trouble with fractions, get out a piece of scratch paper and verify that that is how you divide fractions. This -5 just goes out on the end. It's not inside the parenthesis. It doesn't get divided by -1/2. It just gets moved to the right. So now we complete the square. Half of 5 is 5/2, and that squared is 25/4. Be careful, that's not really a 25/4. If you use the distributive property, I'm not going to draw the other arrows. If you use the distributive property, this is really a -25/8. So I balance out a -25/8 with a +25/8. Next we factor. So we have -1/2. Now remember when we solved quadratic equations by completing the square. This factoring step, you don't have to think hard about it. If you've done the arithmetic correctly, you know this trinomial is going to factor into a perfect square. X times x is x squared. I have negative x's, so this is a minus sign. And then the half number that had to cross our mind, half of 5 is 5/2. That's what's going to go here, because 5/2 times 5/2 is 25/4. So now we need a common denominator, which would be 8. So 5 is, I guess it would be 40/8. So -40/8 plus 25/8. That would be -15/8. Get some scratch paper for dealing with the fractions if you're not all that comfortable adding and subtracting fractions. But this is Vertex form. Now one problem with Vertex form is it looks like this is a two-step process. I mean, you can see on my work here how many steps. 1, 2. However, obviously if you watch this video, there's quite a lot more involved. So this technique does require quite a bit of practice, but it's a really, really useful technique. And once you have standard form, which we started with, and Vertex form, you can do basically anything that you want with a quadratic function. Anyway, that's how you convert to Vertex form. Hope it helped.